Having a look at the area of a sector and the length of an arc today. Now, to establish a couple of things, just a couple of properties about circles. Whenever I draw two radii on a circle, as long as it's not a diameter, as long as it's not straight across the middle, I split that circle into two sectors, the major sector and the minor sector. The major, and the one that we tend to deal with normally is the minor. So this guy's the major. I'm not going to label the minor because I need to go and draw some other things on here. In the same way, when I draw that those same two radii on there, assuming it does not go straight across and form a diameter, I form a major arc and a minor arc. And just as previously, this part is the major arc, and the red one there is the minor arc, which is the one we're going to focus on here. But technically, we tend to deal with either obtuse or acute angles, which is why we tend to deal with the minor arc and the minor sector as well. But we could do the exact same thing with the major ones as well. So two formulas we need to remember here. Now, they are all just based on the couple of basic ones that you would have done in year 8. The first one of those is L, that arc length there in red, equals theta over 360 times 2 pi r. Now I say it's the arc length in red, technically it would work for the one in blue as well. The angle would just be the obtuse angle, not the reflex angle, not the obtuse angle there. Now if we go and convert this angle here into radians instead of degrees. Now our conversion factor for that would be I need to get into radians, so I need to multiply it by 180, and I need to divide it by pi. Now, if I go put all that information in there, I'm going to have L equals theta over 360 multiplied by 180 over pi multiplied by 2 pi r. Now, there's a bit that can go here if we have a look, a bit that can simplify out. Our pi's are going to go, which is nice to not have pi involved there. Our 180 and 360 can simplify. That's going to give me theta over 2 over here, but I've actually got a 2 and a divided by 2, which means all I'm left with here in the end is actually L equals R theta. That's a much simpler formula. That only works if we are dealing with radians, though, not with degrees. If I have 45 degrees and 5 centimeters, I can't just say 45 times 5. But I can do that with radians. And it gives us a nice, easy way to get things in exact values as well. If I did the exact same thing with the area of this, with this sector here, I'd have A equals theta over 360 multiplied by pi r squared. And once again, I would do the exact same thing. I would go and multiply by 180 and divide by pi. I'd end up with a similar thing happening. My 180 and 360 would work together. The pi's would go. And what I'd end up with is I've got theta over 2 and r squared. Now, the way that we normally write this is r squared theta over 2. And again, a much simpler way to deal with things if I've got my angles in radians. Okay, so that's our two formulas we need to remember. The area of our sector is r squared theta over 2, and the length of our arc is L equals r theta. Two nicer ones to deal with that you will get comfortable with using as we move forward. Let's have a look at an example. Having a look here at an example, we're calculating the perimeter of a sector and then finding its area as well. We know the radius is 8 centimeters and it subtends an angle of 3 pi over 4 at the center. So we're going to use our two really basic formulas. L equals r theta and A equals half r squared theta, or r squared theta over 2, means the exact same thing. For our first part here, I'm going to say my length is r, 8, multiplied by theta, 3 pi over 4. Now, 8 times 3 pi over 4 gives me 6 pi. It's 24 pi over 4. To find the perimeter there, I'm going to say it's 6 pi plus 2 times 8 is 16. So that means my perimeter of that shape is 6 pi plus 16, not 6 pi times 16. And I'll add centimeters to that because I need a unit there. My area is going to be half multiplied by 8 squared by 3 pi over 4. Again, I want to put everything in my calculator except for pi, okay? If I don't put pi in my calculator, that means I'm going to be able to go and I'm going to be able to have a nice answer that's an exact value. And my answer there ends up being 24 pi. 24 pi centimeters squared. Okay, now that's a little bit less than 80 centimeters squared, but I don't really want that answer. I want it as an exact value. Exact value always if I can. Now, the third part here, by what amount must this angle be extended so that the arc is 40 centimeters in length? So now I know that L equals 40. So that means that I can go and say 40 equals 8 theta, which means I just need theta to equal 5 radians. Extend that angle by, I'm just going to have to say my extension is 5 minus 3 pi over 4. To turn that into a single fraction, it's going to be 20 minus 3 pi over 4. That's my exact value in radians of how much greater I need this angle to be. And that ends up being, I think it's about 150 degrees. That I need to extend by. I hope this has been helpful to be able to find the length of an arc, or the area of a sector.